Hello everyone, and welcome to the next video on decimals. This is a technical skills video on the topic of ordering decimals. Now I'm going to take this into two stages, take you through this in two stages. In the first stage I will talk about how you order positive decimals, and then we'll discuss how we deal with negative decimals. For positive decimals, we begin by always comparing the whole parts, and if there is a difference in the whole parts, then you can tell which of the two numbers is the larger of the two, and you don't have to even bother with the fractional part. If the whole parts are the same, then we move on to the fractional side, and on the fractional side we'll take a look at the digits place value by place value until we see a difference, and that difference can tell us which of the two numbers is the larger of the two. As an example of this, let's say that we want to compare the sizes of 32.80 and 29.57. Now here we take a look at the whole parts. We have 32 in 32.80, and the whole part of 29.57 is 29, and 32 is larger than 29, which means 32.80 is larger than 29.57. It makes no difference, of course, that we have 80 here and we have 57 over here. It's true that on the fractional side, 80 is larger than 57, but the difference doesn't make up for the difference between 32 and 29. In fact, if you think money, $32 and any number of cents is larger than $29 and any number of cents. So the cent part doesn't really matter. So long as the dollar part is larger, we know which of the two numbers is the larger of the two. Okay, so we write down 32.80 is larger than 29.57. Number two. Now here we have two numbers where the whole parts are the same. Both of them are 0. And in fact, they could be any number, so long as they're the same. Like it could be that we have 14 in place of the zeros, or we have 152. So long as the whole parts are the same, then we move on to the fractional side and compare the numbers, and we go place value by place value. And so we take a look at the tenths. We have a 2, and in 0.193 we have a 1, and that tells us right away that 0.2 is larger. Now you might wonder, you might think that that's strange in view of the fact that 0.2 on the right side has only a 2, whereas 0.193 has 193, and it appears that 193 is larger than the 2. However, this is where I draw your attention back to what I was talking about in the first video on decimals, where I talked about the relative sizes of place values. So if you take a look at the image over here, for example, we are comparing the sizes of 0.1 and 0.09. Now this one has a 1 on the right side, whereas this one has a 9. However, the 1 is in the tenths, and therefore it refers to a size that goes from here to here. Whereas 0.09 talks about 9 hundredths, so we divide 0.1 into 10 parts and we take 9 parts. The size of one piece in the hundredths, it's 10 times smaller than the size of a piece in the tenths, and therefore 9 hundredths refers to a size that's only this long. So it's true that 9 appears to be larger than 1, but owing to the fact that 9 refers to 9 pieces whose sizes are much smaller to make up for the one piece that has a large size going from here to here. That means that 0.1 is larger than 0.09. And here as well with 0.2 and 0.193, now I'm going to show you a diagram on the right side where we compare the sizes of these two numbers. And in this diagram, 0.2 talks about 2 tenths, and therefore if this is 1 tenth, 0.2 refers to 2 of them, and therefore this is where 0.2 is. That's 2 tenths. Now 0.193 talks about 1 tenth, and that would be from here to here, and an additional 9 hundredths, which takes us from here to here, and then 3 thousandths, which takes us from here to where the arrow is. So you can see that although we have 1, 9, and 3, the 1, the 9, and the 3, each one refer to a piece of a different size. And the sizes go down so quickly that, that the 9 and the 3 even together do not make up for the extra 0.1 that we have in 0.2. And therefore 0.2 again is larger than 0.193. And once again, we take a look at the digits on the right side, on the fractional side, place value by place value. And if we see a difference, then we can tell which of the two numbers is the larger of the two. And in this case, 0.2 is larger than 0.193. Now for negative decimals, there is nothing new to say here. The rules are basically the same as the ones that we followed when we ordered integers. The given two integers that are negative, the one that has a larger size is in fact the smaller of the two, and the order is the same as with integers. The ordering of decimals follows the manner in which they appear on the number line. Okay, so number one, let's now compare the negatives of the two numbers that we compared up here. Negative 32.80 and negative 29.57. Now, in terms of size, 32.80 is larger than 29.57, and therefore on the number line it flips over, and negative 32.80 becomes less than negative 29.57. And the second example, now we compare negative 0.2 and negative 0.293. So if you take a look at this diagram and sort of like turn it around, negative 0.2 would be on the left side of 0.193, and therefore negative 0.2 is smaller than negative 0.193. And once again, we can compare the sizes. 0.2 is larger than 0.193, and therefore that means negative 0.2 is smaller than negative 0.193. Now, in addition to being able to order positive decimals and negative decimals, there are other scenarios, and although they are pretty straightforward, I would still like to mention them. Positive decimals are of course greater than negative decimals, and therefore 4.8 is larger than negative 7.9. And positive decimals are greater than 0. All positive numbers are greater than 0, and therefore 3.2 is greater than 0. And negative decimals are less than 0, and therefore negative 3.2 is less than 0. Okay, everyone, that brings us to the end of this short video, and I will see you in the next video.